Hello everybody, Joel Moba here. As a software tester who, for example, works in the test case design, it is really recommended that you use a systematic ways in order to derive the test cases. And there are different techniques. And one of the techniques is called the state transition technique, which will help you not to miss any case where your software can be modeled like a state machine. So what is a state machine? So a state machine is actually when you can represent your system by showing its possible states and also valid state transitions. So generally, a transition will be initiated by an event, and the event sometimes might be guarded by what we call a guard condition, a guard condition that should be fulfilled in order for your transition to take place, really. Okay, and generally the transition, they are assumed to be instantaneous. You can imagine when you light on, the light in your house, So here I show you an example here, a simple example where you have for example, an example with a light bulb. It is on the state off at the beginning, for example, and you do an action, you turn on the light, and the light will then move from the state off to the state on. This is the novice state. And when you turn the light off, then it will now transition again from the state on to the state off. So, but in software domain, there are some systems, some software that you can also model. You can also model as state diagrams. And I want to show you today how you can use these large language model systems, like ChatGPT, Gemini, Mistral, Claude AI, in order to help you to design test cases. So, there is also a test case we generally based on a state diagram. We can also represent that as a state table. It will be a sequence of events which result in a sequence of state changes, and action if needed. So one test case might cover, several transitions between states. And that's why there are different coverage possible with that. So there is, for example, the all state coverage. In the all state coverage, your goals to the items of your coverage are all the states. If you want to achieve 100% of covering all the states, then your test cases must ensure that you exercise all the states. Then the coverage is then measured by the number of the state that you have covered with your test cases divided by the total number of states. And you can express that in percentages by multiplying by 100. You have also what we call a valid transition coverage. In the valid transition coverage that we call also the zero switch coverage, then you will then cover only the valid transition. So the coverage is then the total number of the valid transition that you have covered divided by the total number of valid transition. And you can also express that in percentages. And you have also the third one that we can cover today is the all transition coverage, where you will try to cover the valid transition and also try to do some invalid transition. And then the coverage is this total divided by the total number. But you have to know that the all transition coverage is of course more powerful, and the all state is less powerful than the other one, because with the valid transition, if you do only the all state coverage, you can go through all state without necessarily exercising all the transition. Now, how can we now, as a software tester, use these tools, that of these large language model tools? I will show you that here. Let us go by the start to ChatGPT. Okay, and then I will drop here, okay, a prompt that I have prepared for these circumstances, and I will drop that here and explain you a little bit here this prompt. As a junior software tester, I have to design test cases for different systems having states and transition. So I'm telling the large language model my role here and what I might generally do. Okay, here is how the Praxis Kage ATM. So this is a fake name that I gave here. So if it's a real name, it is just a coincidence. Okay, here is how the Praxis Kage ATM, which is an automated teller machine, and works like. Okay, there is a state 1 that is called either, and the ATM is waiting for a user to insert its card, for example. And the transition, when you insert the card, it will transition to card inserted state. And then I've also put here the state 2. When the card is inserted, the ATM prompts the user to enter the PIN. When you go and take money, for example, for your ATM. Then the system will then, the transition will then be the user enters the code PIN, and the transition to authenticated state because the PIN is correct. Or it will transition, the user enters an incorrect PIN 3 times. It will transition to a card lock state. Okay, like we generally know. And the state 3 is an authenticated. You have now authenticated state, and the ATM offers options like withdraw, or to check the balance, or to deposit money, for example. And you can transition when the user select withdraw or check balance. It can transition to processing state, or it can also transition when you use the exit button, to transition to eject card, like the ATM. The state 4 is processing. The ATM processes the selected transition, and then the transition is, for example, the transaction is completed successfully. Okay, and then it's transitioned to authenticated or eject card state, depending on the user choice. And the last one, the transition, for example, that there is insufficient found and you want to withdraw money, and it will transition back to authenticated with an error message that for example, you don't have enough found. And the state 5, it is eject card. So the ATM eject the card and goes back to idle. It will transition card ejected. It will transition to the idle state again. Now I'm asking now, give me, this is the task. Okay, I had the task. I ask now the ChatGPT to give me just enough test cases to fully test all the state and all the transition. And I will also say, give me the result. Give me the result in a table. Okay, I copy that and I start here. Okay, I will ask the same question to Gemini here. I start. I will ask the same question to Claude. I start. And ask the same question. For example, here, I will start a new chart here, also to them. Okay, let us look what ChatGPT here has found, as test cases, etc. So here it gave me a lack of state tables, when you have, this is the first test case, and initial, it is in the state either, you have the action and you have expected result, and then you have the next step, etc. So that's quite a good work. Okay, here. Okay, and then here I have a state table, but maybe did not really understand that I really want now that it gives it the minimum number. Okay, so give me a test case with transition sequences to cover to achieve 100% coverage. Okay, here I said this. Now test case transition, it's giving me much more here. Okay, let us look at Gemini understood that. Insert card, I also have here a table, and it also gave me some examples here. So that's interesting. Here I have 10 test cases, for example. I don't go to the details here. 12. Okay, and let us look at what Claude is saying here. And I have also this here. Let me look here. Yeah, I have state coverage metrics. I have transition coverage metrics. You know, it looks like I have more details here with Claude, description, verify basic card insertion. So it gave me here some goals for this one. Here I have 9. So something, this is called the artifact. Okay, I will say simulate it for me. You know how we ask Claude because they have this possibility. Let's see if Claude also can do that for me. Let us look at here to Mistral. Okay, Mistral here gave me also state 1 idle, the system is waiting, transition, user encoded. So this is, I enter this. Here I have also different test cases. Okay, that's great. That's great. Also here I have different test cases. I can look here and see that okay, these test cases cover all the states and transition. So with this might not be the minimum number of test cases, but here I have already a set of test cases that's helped me to cover, you know, all the states and all the transition, right? Let us see if Claude succeeded here. You see, in Claude we have this feature. When you see in the artifact here, I have directly here, for example, let us check it. Available action. You see here I have a state. Okay, it gave me, for example, a simple system. It can be visual. You can even publish it, you know, share that with customer, with colleagues, and they can access it. For example, you can download the file, and this is interesting here. And then I can ask Claude, it looks like insert card. When you insert card, card is 1, 2, 3. And then I have enter pin, you know, I have, you see the state action. You see, it's interesting. Incorrect pin to attempt. Wow, that's interesting. You see, this feature of Claude, you see, can really help you. Enter pin again, incorrect, remain 1. If now it has moved to current set authenticated, for example, available action, you see, withdraw $100, check balance, exit. If I select exit, it has to go back to card ejected, and it should take the card. That's amazing. You see, even with Claude, you have the possibility here to simulate your system because they have this inside, you know, and then you can play and discuss, for example, with your stakeholders, you know, if this is the way the system should really work. Even if the system is not developed, you have in a kind of quick prototyping. It's amazing, right? And you as a software tester, you can also use that in order for you to better understand user story, the system, the testability, if you went through all the different possibility test cases. So this is how these systems can really help you, okay, to be more effective and efficient as a software tester, you know, to create, to design test cases. I hope it was really helpful to you. If you really enjoyed that, so please like, subscribe, you know, and click the bell button so that you don't miss the next videos. Okay, I wish you happy testing. Bye bye.